Here are your instructions for 8-6. 8-6 is about changes in dimensions. So let's look at our first key concept here. If a solid x is similar to solid y by a scale factor, then the surface area x is equal to the surface area of y times the scale factor, the square of the scale factor, times the square of the scale factor. Keep in mind that it's easy to remember that it's the square of the scale factor, because when we're talking about area, we're talking about square units. So whatever the surface area of the first figure is, we multiply it by the square of the scale factor in order to get the second figure. Let's take a look at what that looks like. Okay, cubes are similar solids because they have the same shape and their corresponding linear measures are proportional. So in this case we have a 4-inch side, and in this case we have an 8-inch side. So obviously our scale factor is 2. So we want to know how are the surface areas related. Well, the surface area of the small cube, we have a 4x4 side, and we have 6 of them. 4 around the side, the top and the bottom. So we have 6 times 4 times 4, or 6 times 16. That would give us our surface area. In this case, we have the same 6 times 2 times 4 because we have a side length of, or I should say a scale factor of 2. Our scale factor is 2. And then we also have the same thing here, 2 times 4. So we would have 2 times 2 right here, times 6 times 4 times 4. Or in other words, we can see that we're multiplying by the square of the scale factor. It would be 2 squared. So we could multiply 6 times 4 times 4, get the surface area of the small cube, and if we multiply that by 4, or 2 squared, that would give us the surface area of the second. Remember, it's easy to remember that, and because it's surface area, because it's area, which is a two-dimensional object, we're going to multiply it by the square of the scale factor. Take a look at problem number 1. The surface area of a rectangular prism is 78 square centimeters. So you don't have to do any calculating or anything here. They have given you the surface area of the rectangular prism. So that would be something that looks like this. And they're saying the surface area is 78 centimeters squared. Okay, if we drew another rectangular prism 3 times as large, what would the surface area of that be? So it's a matter of multiplying it by the square of the scale factor, which is 3 squared, which of course is 9. 78 times 9, we would have 702 square centimeters of one that is 3 times the size. Please press pause and do letters A and B. Show all your work. Okay, now let's take a look at volume of similar solids. The process is very similar with one small change. If solid X is similar to solid Y, again by a certain scale factor, then the volume of X is equal to the volume of Y times the cube of the scale factor. And if you think about it, that makes perfect sense, because volume is a 3-dimensional thing, so we would talk about cubic units, so you're going to multiply it by the cube of the scale factor. So let's take a look at what that means. Refer to the cubes below. Again, we have a 4 by 4 by 4 inch cube, and we have an 8 by 8 by 8 inch cube. So obviously our scale factor equals 2. It is twice the size. Okay, so the volume of the small cube is 4 times 4 times 4, whereas the volume of the large cube is 2 times 4 times 2 times 4 times 2 times 4. These, of course, are quantities in each of these cases. So it would be 8 times 8 times 8. But the key is we can pull out these 3 red 2's here and recognize that it's 2 cubed, which of course is our scale factor cubed. So remember, when it comes to volume of similar solids, they are related by the cube of the scale factor. Really easy. Take a look at how that works. Problem number 2. A triangular prism has a volume of 432 cubic yards. So again, we have a triangular prism here. One of these that looks like this. And it has 432 yards and these are cubic units. If the prism is reduced to 1/3 its original size, what is the volume of the new prism? Well, as we've been learning, we are going to take the volume that we started with and multiply it by the scale factor. Since it's 1/3 its size, the scale factor is 1/3, and we are going to cube that scale factor. Now remember, when it comes to fractions, when we multiply 1/3 times 1/3 times 1/3, we end up with 1 over 3 times 3 is 9 times 3 is 27. We end up with a much smaller number. Understand that when you're working with fractions, when you're cubing a fraction. Fraction times a fraction is going to give you a smaller number. So of course we end up with 432 over 27. And 432 divided by 27 is 16 cubic yards. So we go from 432 cubic yards down to 16 cubic yards. Please press pause and do letters C and D. Problem number 3. The measurements for a standard hockey puck are shown at the right here. The giant hockey puck at the left, so this is obviously the outside of a building, and this is the advertisement of the ice house. It is 40 times the size of the standard puck. Find the volume and the surface area of the giant puck. In this case, they want you to use 3.14 for pi. We are not going to do that, but in this case, that's what they did, so we'll just go with the numbers that they have here. First of all, you have to find the volume and the surface area of the standard puck, because those are the only things we're given the dimensions for. So we have a radius of 1.5, and we have a height of 1 inch. So we have pi r squared, so it's pi times the radius, 1.5 squared, times 1. Do the math, and we end up with 7.065 cubic inches. For surface area, remember the formula is 2 pi r squared plus 2 pi r h. So it's a matter of recognizing the radius and the height in the diagram and plugging them into the formula. So we have 2 times pi times 1.5 squared, the radius, plus 2 times pi again times the radius of 1.5 times the height. Do the math, and we get 14 and 13/100ths plus 9 and 42/100ths, and that's 23 and 55/100ths. Notice that we're using the approximate. Find the volume and surface area then of the giant puck using the computations for the standard puck and the scale factor. So we have a scale factor. Our scale factor is 40 times. So for volume, we're going to take the volume, which is 7.065, and multiply it by the cube of the scale factor of 40, and we get 452,160 cubic inches. For surface area, we're now talking square units in area, so we're going to multiply that surface area that we found right here times our scale factor of 40 squared. So it's going to be 23 and 55/100ths times 1,600, and we're going to get 37,680 square inches. And of course, then we would just report those two answers. Please do guided practice.